Last night you dreamed. You almost certainly did for 1 to 2 hours, in fact. You ran, you spoke to people who don't exist, maybe you flew or fell or stood in a room from your childhood that hasn't existed in 20 years. And by the time you poured your coffee this morning, almost all of it was gone. Not faded, gone. As if it never happened at all. For most of human history, people assumed dreams simply weren't real memories, just smoke that burned off at sunrise. But in 1953, two researchers at the University of Chicago discovered something that changed everything. Eugene Aserinsky and Nathaniel Kleitman noticed something strange happening to sleeping volunteers. Their eyes, closed and still for hours, would suddenly start darting back and forth, rapidly, as if watching something. They woke the volunteers during these moments and asked what was happening. Almost every time the answer was the same. They had been dreaming, vividly, in real time. The researchers called it rapid eye movement sleep, REM for short, and for the first time, science had proof that dreaming wasn't some vague mental fog. It was an active, structured experience happening inside a sleeping brain, every single night, multiple times a night. So if dreams are that vivid, that frequent, why can't you remember them? The first part of the answer comes down to chemistry. While you're awake, your brain is flooded with a chemical called norepinephrine. It's one of the main ingredients your brain uses to lock experiences into memory. But during REM sleep, something remarkable happens. Norepinephrine levels drop to almost zero. Your brain is having an experience, a vivid one, but it's doing so without the chemical it normally needs to write that experience down. It's like a camera recording video with no memory card inserted. The footage exists for a moment, on the sensor, in the moment, and then it's simply gone. But that's only part of it, because even if your brain wanted to write the memory down, there's a second problem. The part of your brain responsible for that job is barely switched on. The hippocampus, the structure that converts short-term experiences into long-term memories, communicates constantly with the prefrontal cortex while you're awake. That connection is what lets you remember a conversation an hour later or recall what you had for breakfast. During REM sleep, that connection weakens dramatically. The hippocampus is still active, almost frantically so, but it's largely cut off from the regions that would normally stabilize and store what it's processing. Your dream is being generated in real time, and almost nothing about it is being filed away. And here's the part that makes this even stranger. In 2010, researchers used brain imaging to study people right as they woke from REM sleep. They found that the people who could recall their dreams in detail had one specific thing in common: a brief surge of activity in the temporoparietal junction, a region near the back of the brain involved in attention and awareness, right at the moment of waking. People who couldn't recall anything showed almost no activity there at all. In other words, whether you remember a dream or not might come down to a tiny window, just seconds long, right as you wake up, where your brain either grabs the dream and pulls it into consciousness, or lets it slip away forever. Now here's where it gets interesting, because not everyone loses that window the same way. In the late 1960s, a French researcher named Michel Jouvet was studying cats and REM sleep when he made an accidental discovery. He damaged a tiny structure in the brainstem of some cats, and something bizarre happened. The cats started acting out their dreams. They'd be fast asleep, eyes closed, but their bodies would move, stalking, pouncing, hissing at things that weren't there. Normally, during REM sleep, your brain sends a signal that essentially paralyzes your muscles, so your body stays still while your mind runs wild. Jouvet had disabled that signal in the cats, and what came out was raw, unfiltered dream behavior. Decades later, doctors started seeing something eerily similar in humans. People with a condition called REM sleep behavior disorder don't just dream vividly, they physically act it out. Sometimes violently, sometimes for years before anyone realizes what's happening. And when researchers studied these patients, they found something else. Many of them could recall their dreams in extraordinary, almost cinematic detail, night after night, for years. But the group that changed how scientists think about dream recall entirely wasn't a clinical population at all. It was a small percentage of completely healthy people who, for reasons nobody fully understands, remember a dream almost every single night of their lives. Researchers call them high dream recallers, and when scientists put them in brain scanners, they found the difference wasn't in how much they dreamed. Everyone dreams roughly the same amount. The difference was in that brief waking window. High dream recallers showed dramatically more activity in the temporoparietal junction at the moment of waking, and their brains were more easily roused by external sounds during sleep, meaning they spent more time in a light, hovering state between sleep and wakefulness, the exact state where that fragile transfer of memory has its best chance of happening. And this isn't a purely modern mystery either. People have been trying to hold on to their dreams for thousands of years. Ancient Egyptian priests kept dream journals on papyrus, believing dreams were messages from the gods that would vanish forever if not written down immediately upon waking. Roman emperors employed professional dream interpreters who slept in the same room, ready to record an emperor's dream the instant his eyes opened because everyone understood the same basic problem. Wait even a few minutes and it's gone. In the 1600s, some scholars trained themselves to wake up multiple times a night specifically to scribble down fragments before they slipped away, filling notebooks with half-finished sentences and disconnected images that made perfect sense at 3 a.m. and almost none by sunrise. What's striking is that none of these methods actually improved anyone's natural ability to remember. They were workarounds, ways of racing the clock rather than stopping it. The dream was always going to dissolve. The only question was whether you could get a pen moving before it did, which means for every culture, in every era, humans have been fighting the exact same losing battle against the exact same few-second window, the one where the door between sleeping and waking either stays open just long enough or slams shut for good. So why would evolution build a brain that generates something this elaborate every single night, only to throw almost all of it away? For decades, the leading idea was called the continuity hypothesis. The theory goes like this: your dreams aren't random noise. They're built almost entirely from the same material as your waking life. Researchers who collected thousands of dream reports found that the people, places, and emotions in our dreams overwhelmingly mirror whatever we were dealing with the day before or the week before. Stress about a deadline shows up as a dream about being unprepared for an exam. A fight with a friend shows up as a dream about being chased or abandoned. Your brain, while you sleep, appears to be running simulations using the raw material of your actual life. If that's true, then forgetting might not be a flaw in the system. It might be the entire point. The dream's job isn't to give you a story to remember in the morning. Its job is to process something while you're unconscious, to run the emotional simulation, file away whatever needs filing, and then clear the workspace before you wake up. A factory doesn't need you to remember every part that moved on the assembly line overnight. It just needs the product to be ready by morning, which means every night your brain may be quietly working through your fears, your stress, your unresolved moments, using a version of you that exists for a few hours and then disappears completely. Its entire job complete the moment you open your eyes. So the difference between someone who remembers their dreams every night and someone who remembers almost nothing isn't that one person's brain dreams more, or dreams more vividly. It's that one person's brain is slightly more willing to let the door stay open for those few seconds between sleeping and waking. A door that, for most of us, slams shut almost instantly, every single morning for our entire lives. Which raises an uncomfortable thought. If your brain is generating an entire experience every night, complete with emotions, sensations, entire imagined worlds, and then deliberately discarding nearly all of it before you're even conscious enough to notice, how much of what's happening inside your mind right now, while you're awake, is also slipping away the moment it happens? Somewhere last night, you were back in that room from your childhood, the one that hasn't existed in 20 years, talking to people who don't exist, and your brain has already decided you don't get to keep it. You've spent roughly a third of your life so far in a state your own brain has chosen to erase. Not because nothing happened there, because something happened there every single night, and your brain simply chose for reasons it never asked your permission for that you didn't need to remember it.